In this example, we're still working with s'mores as our chemical analogy. We still have the same balance equation, 2 graham crackers plus 1 marshmallow plus 1 chocolate will make 1 s'more. But this time I've changed the starting values on you. We're starting with 14 graham crackers, 6 marshmallows, and 8 bars of chocolate. And this time we're not going to draw a picture, because a lot of times in chemistry we're not able to draw pictures for every single thing. So I'm not always going to have a visual. I need to be able to complete a BCA table without a picture. And so we're going to start with the before, listing the starting quantities of every single thing in your reaction. The given tells us that we're starting with 14 graham crackers, 6 marshmallows, and 8 bars of chocolate. And we're going to make 0 s'mores. Or we start with 0 s'mores, I'm sorry. The change row. We know that the limiting reactant is the one reactant that is completely used. It's going to end up being 0 at the end. What I'm looking here, is it going to be the graham crackers, the marshmallows, or the chocolates? I don't know, because I haven't drawn my picture yet. So how do we go about this without a picture? What I want you to practice is assigning the first reactant as a limiting. I'm not saying that it is limiting for sure, but we're going to test it, and we're going to see if it was limiting, how much of everything else would we need. So assuming graham crackers is limiting right now, we're going to subtract all 14. So that limiting value gets copied over to all the other columns. Reactants get minus signs, products get plus signs. And then we multiply by that mole ratio, aka the coefficients. You can think of that change row as coefficients. They both start with C. So for the marshmallow, it is what you're solving for, in this case the marshmallow, its coefficient, over the coefficient of the limiting. Our limiting reactant right now, we're saying, is graham crackers, and its coefficient is 2. So I put a 2. And I'm going to calculate this real quickly. 14 divided by 2, that gives me 7. And I want you to pause and evaluate what this is saying. We're saying in order to use all 14 graham crackers, 7 marshmallows would be required. But look here, we only have 6 marshmallows available. So it's impossible to use 7 of them. So there's no way that we're going to use 7 marshmallows because we don't have 7. And so that means we don't have enough marshmallows. So graham crackers cannot be the limiting reactant here. So because this is happening, this change row is now invalid. And we're going to cross it out. So this change is not happening because you don't have not enough marshmallows here. So we're now going to ignore that change row. Now, we're going to assign the limiting reactant to the next reactant and test it again. So we're going to minus all 6 marshmallows, and again, since we're saying that's the limiting reactant, we're going to copy its value to all the other change boxes. Reactants get minus signs, products get plus signs, and then we multiply by that mole ratio, aka your coefficient. And it's the coefficient of what you're solving for over the coefficient of the limiting. So since we're solving for graham crackers here, its coefficient is 2 divided by the coefficient of the limiting reactant. And remember, we said, let's assume marshmallow is limiting. Its coefficient is 1. So I'm going to put a 1 on the bottom. And I'm going to repeat this for all the other reactants and products. So for the graham crackers, 6 times 2 is 12. And you pause and reflect. Do you have enough graham crackers? Yes, you do. There's 14 available. We only need 12 for the change, so I'm going to continue. So this looks good so far, but let's check to make sure that we have enough chocolates for this complete reaction. Chocolate has a coefficient of 1. Coefficient of our limiting right now is the marshmallow, and that's a 1. And so 6 times 1 is 6. And you pause and you evaluate. Do you have enough chocolates to complete this reaction? You started with 8. Our change is 6. Yes, you have enough. So we're going to keep on going. So that must mean, yes, the marshmallow is the limiting reactant. And that limiting reactant value determines how many s'mores we're able to make. So for the s'mores column, its coefficient is 1. The limiting reactant, again, is marshmallows, and its coefficient is 1. So we're going to end up making 6 s'mores. So that after row is a combination of the before and the change row. Graham crackers start at 14. We use 12 graham crackers. So at the very end of the reaction, 14 minus 12, there should be 2 graham crackers left over. For the marshmallows, since it's limiting, we expect it to be 0 at the very end, and indeed it is. 6 minus 6 is 0. For our chocolates, 8 minus 6, we'll have 2 chocolates left over. And for the s'mores, it'll be 0 plus 6. We'll end up making 6 s'mores. So I have my complete BCA table, and I have the full picture from start to finish of this reaction. We know how much of everything we started with. We know how much we used and how much we made. And at the very end, after the reaction is done, we know what quantities that we have in our container. Number of s'mores produced. I go to that after row. We made 6 s'mores. The limiting reactant is going to be the one that is 0 at the end of the reaction. So I go to the after row, 0, marshmallows here. And we're going to highlight that column for emphasis. That's your limiting value. Whichever one reads 0 at the end of the reaction is your LR, your limiting reactant. This one is marshmallows. The excess reactants are going to be those reactants that you have extra of. So you have extra graham crackers and you have extra chocolates. And the quantity remaining of each one, you have 2 graham crackers and you have 2 chocolates left over. So in our BCA table, we've highlighted the limiting reactant column. Its coefficient appears in the denominator of all the mole ratio fractions. So remember, the coefficient of marshmallow was 1, and you'll see here in red, that's why I have a 1 in the denominator of all those fractions. And another thing, the limiting reactant is completely used, so its value gets subtracted or added to all the other change boxes.